Hello to everybody and welcome to this talk from HiRef. We are Fabio Poletto
and Matteo Faccio,
and today we will discuss about sustainability in the data center applications. Well, we can start asking to Matteo to give us a focus about the last trends in the data center market. What you can say about that, Matteo?
Thank you, Fabio. I think that we can start having a look on what happened the last 2 years and what is going to happen in the future. So we have seen a continuously increasing data creation leads that is bringing to an increasing demand for data center, especially due to the new emerging technologies like 5G, self-driving car, and other interconnected devices that are becoming even more and more. Then, of course, we cannot forget the growth of the colocation and the cloud services that are also this one are bringing medium and hyperscale data center development increasing. Looking up to what Frost & Sullivan report show in January 2021, we can see this graph that is showing that since 2018 up to 2025, we can see continuous increasing demand for data center investment, and then with a constant growth of more or less 10%.
Okay, this is very interesting for the future of this market, but we know also that the data center infrastructure are very energy demanding. So with this growth rate, how is it possible to make it more and more sustainable looking to the available technologies?
Yes, I think that we need to have a look on the cooling impact for the data center efficiency. But first of all, having an overall view of a data center, we can see a system that is using a lot of energy. So everything inside is absorbing energy. And of course, everybody knows what a PUE is. So focusing our attention on how is determined the PUE, we can have a look on this graph that it's representing a PUE of 1.9. But at the end of the day, in this graph, we can see what is really used by the end user, by the target. So it's only the 52% of the total energy consumption. All the rest, we can consider it like waste energy, okay? But it's, of course, mandatory to make the system running properly. Of this rest, the 40%, almost the 40% of energy is used for the cooling. So I think that we will have a big opportunity to work on this 40% in order to get major benefit of the PUE. What can we do? Basically, we can work in 3 different main arguments. First of all, we need to take care about the operating condition inside the white space. HiRef is indicating this, so it's really important to follow the recommended operating area, and in case of possibility, have a look also on the acceptable operating condition. Secondly, we need to focus our attention to use as mandatory a containment system for the organization of the room. This simple CFD analysis is showing in a clear way what is happening without the containment and with the containment system. Last but not least, we can use also on the exceeding number of units normally used for redundancy. For example, for tier 3 or tier 4, we have N+1 or 2N configuration. We can use this exceeding unit in order to make also them running and finding a balance with a better efficiency working point. But the key point is the temperature. The temperature inside the white space has been increasing reaching up to the limit, and this is giving the possibility to take advantage of the indoor environment using the free cooling. We can use the free cooling in a direct way, so we can bring directly external air into the room, or we can use the free cooling in the indirect way, so we can use an intermediate media such as a cross-flow heat exchanger or a water loop to take the advantage of the free cooling.
Thanks, Matteo. This is very promising for this application, but you have mentioned the direct free cooling, so the external air that comes inside inside the room. So this is very good for the potential, but from what I know, this is dangerous in the data center application for the pollution that is in the air. What can you say about that?
This is completely true, Fabio. With the direct free cooling, we have the risk to bring inside the data center of a lot of substances, such as smoke, product of combustion, chemical components, dirt, and And to avoid this and to make the system running properly using the direct free cooling, it's required to add additional filter, additional monitoring system that are all affect negatively, in a negative way, the data center efficient. I think that we need to focus our attention in this talk about the indirect free cooling. And in the indirect free cooling, we have two main systems to use it: the air-to-air indirect free cooling and the air-to-water indirect free cooling. Let's start having a look to the air-to-air solution. And I like to start looking this picture that is a real installation we have done in Europe, and the unit in the picture are showing a 3-in-1 system. So it means that this unit is able to work in 3 different working modes. The most used one is the dry free cooling, when the external temperature is lower than 21. And this way, the big cross-flow heat exchanger that is inside the unit is giving the opportunity to transfer the cooling capacity from the external air to the data center airflow volume. When the external air is increasing the temperature and then is exceeding the 21 Celsius, we can activate an adiabatic system that's spraying water in the external airflow stream. We can extend the free cooling thanks to the evaporative effect. And then we can move to the dry free cooling to the wet free cooling. And this is working until the temperature, in this case, wet bulb temperature, is reaching around 23 Celsius. And in this case, only in this period, the compressor starts providing the top-up mechanical cooling. Of course, it's up to the customer to decide to size the compressor for the nominal cooling capacity in order to have a full redundant system inside the same unit.
Okay, this is interesting. And but you mentioned that in this application we use also water. As we know, water is very precious for the air flight. And how is it possible to make it sustainable in this kind of application?
Oh yes, it's really important, the water, and also for that reason it has been introduced a new parameter to evaluate how much the unit is able to use and to save water. So this is the WEV, that is exactly the brother than the PUE, considering the water instead of the electricity. There are many different systems to use the adiabatic technology. We can provide two. The most used one is to spray water directly into the airflow stream at medium-low pressure. Yes, and the other possibility is to use a pad system. So it's like a sort of made of cardboard or other material that are getting completely wet, and then the air going through this element is getting the benefit of the evaporative effect. You say that water is a primary source, that we need to find a way to manage it in the most convenient way, at least. So for that reason, we can activate two different functions. The water saving function, that is, how the name is saying, that it's a function that is limiting the use of water up to the limit that the unit is not more able to work without it, or we can activate the energy saving function. In this case, for certain latitude or for certain region where the water is not a problem and it's cheap, we can use the water as much as possible in order to decrease the energy power consumption. We need to take in mind that normally to produce energy, apart for the renewable case, to produce energy, the system is using a lot of water, is wasting water. So if we can save energy in the data center cooling, it means that we can save also water in the electricity production. Moving to the indirect free cooling in air-to-water version. In this case, we are talking to a more conventional system to produce the cooling. Of course, we will have outside free cooling chillers or other type of units such as dry cooler or cooling towers. Inside the data center, we will have units able to distribute this capacity. But the most interesting things in this argument is thanks to the higher temperature inside the white space, we can increase the temperature level of the water loop at really high values such as 2030, 2032. This is giving the possibility to extend the amount of hours that the unit is able to work in free cooling mode. Okay,
so but with such high temperature in the cold water production, so you mentioned 2030. So how is possible in this kind of application using mechanical cooling? You mentioned the use of chiller, for example. So how is possible?
Yeah, this is one key point, and of course we need to take some technology advantage, and it means that we can use new type of compressor, new type of refrigerant that is giving the possibility to operate with an enlarged envelope range. Here we can see an example of an envelope of a new type of compressor, that it means that we can move the operating area from the standard water production 710, let me say, in this range, to the new type 2025 as a cooling production. We can see also in this graph here the possibility to extend the availability of free cooling, not anymore, I would say, below 0, but we can say below 15 ambient, we can keep on using free cooling. Of course, if we integrate the adiabatic system to this kind of unit, so again, new type of refrigerant, new type of compressor, and the adiabatic technology, we can still increasing the amount of hours that the unit is able to run without the compressor. Compressors that are still mandatory, because we need to consider some worst case scenario that, for example, we do not have water, or the external temperature is so high and that the compressor must run in order to provide the cooling capacity. We need to say also that in some cases, in a specific region of the world, it's also possible to run a data center without chillers. So in this case, this is an example of a data center with only adiabatic coolers outside, but also in this case, customer always likes to have some mechanical cooling as a real emergency condition.
Okay, we clearly understand how it's possible to increase the efficiency in the cold water production. But now looking to the data also, what is possible to do in the distribution of the load to the system in order to create efficiency on that side?
Oh yes, also inside the unit, inside the room, we have the possibility to use a specific unit design to work with this high water ring, high water temperature ring. So it means that we need to have a unit specifically designed for heat, with a big exchanging surface, with some specifically designed circuitation of the coil. And in order to work with lower water flow amount inside the unit, we need also to consider that in case of chilled water unit, the fan power consumption will represent the only source of consumption. So it means that we need to design a unit with a very low pressure drop inside in order to provide high efficiency to the cooling distribution. We still have some other possibility like rack coolers or conventional crack in order to cool down more conventional room, or some specific cases where we have high density application. Then what is really interesting to talk about is a new type of unit that is taking place, even more place in the cooling distribution, that is the fan wall. In this case, the fan wall is substituting, let me say, a wall of the room that is becoming an active wall. So it means that from this wall we can distribute cold air directly into the room. All the room is cold, flooded of this smooth air that is navigating through the racks. All the hot air is contained in the hot eye containment, and then is coming back through the double ceiling into the unit. I've said double ceiling because this type of unit are designed for no raised floor data center. So it means that we can save money of the technical floor. We can also save time, because normally it's time spending to build all the double floor system. And this unit is modular and scalable, and thanks to the really low pressure drop of the system, we can lower the PUE and getting a really good performance of the cooling distribution.
Okay, now it's clear how it's possible to optimize free cooling on the production of the cold water and in the distribution of the load. But there is something that we can do also in the regulation, in the control of the two sides in order to increase and optimize the using of free cooling. What we can say about that?
We can say that we are missing the third key element, and we can have a very efficient production of cooling. We can have a very efficient distribution of cooling, but then every installation, every data center is different than others. Every customer likes to have different behavior of the system. And for that reason, with HiNode, we can combine production and distribution to the real customer desire and specification. So in this case, with the HiNode, we can, I have put in this presentation 3 different screens of it, where we can see the main all with all the units running. We can plot inside the psychrometric chart the working condition of the data all of the same day or of an entire week to see if we are still working inside the recommended area, and we can have a quick overview of every unit present in the system, either the production and the distribution, giving also the customer a single point of contact to the entire cooling system. So the customer is not looking to manage the unit, but is looking to have a constant air temperature control inside the room.
Okay, very interesting, Matteo. There is another aspect to consider, I think. We have shown how to optimize efficiency in data center cooling, mainly dedicated to new infrastructure, new building, where we have the possibility to design from the white paper the system. But we know that on the market exists a lot of buildings that need to be refurbished by the owner, that needs to increase efficiency and power density in order to be more competitive on the market. What we can suggest to this kind of data center to do for the future?
That's true, Fabio. There are a lot of data centers still running and not yet arrived at the end life, let me say. So we need to give this customer a solution. We need to give this customer a product that is ready for an efficiency upgrade. And this is the example of the unit that you can see here in the slide. This is a unit that is completely flexible. It's able to work with the old low temperature like 712 or 1015, and is able to be installed in an hot swappable condition. So it means that you can replace older unit with this new unit with the data center running. That is another key point to grant continuity. And when all the units will be substituted to the new one, these units are capable to switch to the future scenario, and so it's able to work with a higher water temperature, for example 2032, is able, giving the possibility to increase the free cooling capability of the system. The unit is designed to control the supply air temperature and not anymore the return air temperature, and so with this simple relative modification, we can achieve up to the 40% saving of the cost of cooling distribution and production. On the other side, in terms of retrofit and refurbishment, it's also possible to work on the server racks. So we have seen the advent of liquid-cooled servers, and this will become even more popular and popular in the next years. So it means that with this type of new technology, we can increase the power density and driving also to an increasing of the computational capacity, reducing the cost of the system. Our role in this new scenario will be to manage the cooling water production, the cooling water distribution, and also to give the possibility the customer to manage the heat dissipation from the data center.
Okay, very interesting, Matteo, also for this last point. You have mentioned the heat dissipation. So this is the key for the next question. For the future, we have also to consider to make the data center more sustainable. That is not a waste heat, but it's something that we can reuse and integrate in a larger water loop. And we can make it sustainable, integrating this in a larger system with all other possible usage of heat. But I think that this is a very important argument that we can discuss in the future, and we will dedicate a meeting to that. And so we will appreciate if you will be with us in next October. Say thanks to Matteo for this presentation.
Thank you for your time.
Thank you for your time and watching this video.
Bye bye.
Bye bye.